All right, welcome to the practice quiz for lessons 16 through 22 on Unit 2, Algebra 1 practice quiz. So the first thing in lesson 16, Sol talks about elimination. So when it's like this, elimination is easy. We just add the two things together, and we get 8x cancels out equals 16, because negative 32 and 48 is 16. We divide by 8, and we get x is 2. You're not done until you get y, so we back substitute, and we'll put y back in. First equation, second equation, it doesn't matter. Pick the easiest one. I'm going to go with the equation that has less negatives in it. So I'm going to use the second equation. Excuse me, it's right after school, so Mr. Jackie's tired. 48. Okay, then we just algebraically solve for the y. This times this is 6 plus 6y is equal to 48. We divide or subtract over the 6, and we get 6y is equal to 42. Y is equal to 7. So those are the two answers, 2 and 7, and it should work in both equations. If you're not sure, you can always check it. On this one here, number 2, we have to manipulate one of the equations so it eliminates. So I'm attracted to the fact that this is x. If I made this negative x, that would be awesome. Also, if this was 6y, you can make that negative 6y by multiplying by negative 6. It works either way. So I'm going to multiply this equation by negative 1. So I get negative x minus y, and then plus 3. Whoops. That's why I have white out here. It's not plus 3, it equals 3. Equals 3. There we go. So multiplying by negative 1 makes this negative, makes that negative, and makes that positive, because a negative times a negative is positive. Then I copy down the first equation right underneath of it. It doesn't matter. You could switch this could be the first equation, that could be the second one. It makes no difference. Add the two equations together, that eliminates. This makes 5y and 15. Y is equal to, by dividing by 5, 3. Now we back substitute. My water out of the way here. Back substitute. Put the 3 back in. I'm going to put it back in the this equation right here. Yeah, so it's x. I'm putting put it in this equation, or the second equation. So x plus y, which is 3, is equal to negative 3. We subtract the 3 over, we get negative 6. So negative 6 and 3 are the two answers. So this question is basically the same question. What can two lines do? Two lines can be the same line. Two lines can intersect. And two lines can be parallel. And so what's going on here is in this is a line, this is a line, this is a line, that's a line. The lines intersect at these points, 2, 7, and 3, and negative 6, 3. But what's going on here is asking the questions, when is it the same line, when do they intersect, and when is it parallel? So if you're going along, and you solve and you get 6 equals 6 is your last step in solving linear system of equations, it means there are infinitely many solutions. Notice it's 2 words. And if the two lines are the same line, right? So the two lines are the same line, like this situation. So if you're going along and you get 6 equals 7, something that's not true, if you get a 6, 7 situation here, in your last step, it means there are no solutions, and the two lines never intersect, right? So they are parallel. Can't spell after school. I'm tired. Parallel. The way I always remember to spell parallel is that there's two L's right there, which are parallel to each other. But man, that was a terrible spelling of it. I need a nap. Oof. Okay, so now we have a situation where we're writing inequalities. So the next thing after the elimination stuff in the systems of equations was inequalities. He has oh my gosh, he has $25 to spend on grapes. They are $1.99 a pound. So it's $1.99 times each pound. So it's $1.99 times X. He has a budget of $25. So he can spend up to $25. So it's less than or equal to 25. And then if we change the price per pound, it's $2.49 less than or equal to $25. So when it says you have a budget of 25, that means you're always equal to, because you can spend right up to your budget. And that would be the two equations. Okay, solve and graph. So by graphing, you're not making the XY graph, you're just making the number line graph. Subtract 7. And then we're going to divide by a negative. Uh-oh. Whoop, whoop, whoop. Warning, warning. When you divide by a negative, you always flip the direction of the inequality. So it becomes X is greater than. So we put 0 on the number line, we put -4 on the number line, and it's equal to, so we make it solid. And we want X is greater than, so we shade the greater side, the bigger than that. And what's right there, that's an arrow indicating this goes forever to the right. The next one, I always say move the smaller amount of X, so we add 18X over plus 18X over gives me 25X minus 3 greater than 72. Add over the 3, and we get 25X is greater than 75. If we divide by the 25, we get X is greater than 3. There's no flipping of the inequality because I didn't divide by a negative or multiply by a negative. Greater than 3, there's 0, there's 3. Open circle, we want greater. Greater is to the right. This is also greater. It appeared to be less than in the beginning, but now it's greater. Okay, this page here, Len's job pays $8.25 an hour. He needs a new job, plus $10 of transportation each week. Len can earn up to $175 a week. So up to $175, but you can't go over. So that's a limiting factor. So it's $175 less than or equal to. So they can earn right up to $175. I would say equal on this, the way that I think it should be. And then it's number of hours, so it's for each hour, right? You get $8.25 X, and then you get your $10 allowance for travel. So we're going to solve this algebraically. So we're going to move the 10. This would tell us how many hours that Len can work in a week. 165. Divide by 825, divide by 825. X is less than or equal to, on the calculator, 165 divided by 825. 20 hours. That's a good part-time job, 20 hours a week. So 20 hours or less. That's what that means. All right, so now we are we're raising money for an after-school program in elementary school. A group of parents is hosting a weekend games in the community center. They charge $8 per person for entry into the event. The group would like to make at least $600 after paying for costs of renting the space, which is $40 an hour. So they're gaining money, right? They're gaining money. that's the 8x, they're losing money by taking the 40y away, but they want to be greater than 600. They want to make at least 600, so that means they could make 600, so they want to be greater than or equal to 600. So I would say D on this bad boy. So they would be, there's your money coming in, that's your money going out. I want to be greater than or equal to 600, so at least 600. So I want to be more than the 600. Okay, last two, we're going to graph. This one's already solved for y, so I don't have to do anything. Y is greater. You want the big Y values, so that's above. And it's there's not equal to, so it's going to be above and dashed. Whoops, I spelled dashed. D-A-S-H-E-D, dashed. Okay, so starting at 5 with a slope of -1/2. So go to 5, slope of -1/2. Down 1 over 2, down 1 over 2. I said down 1 over 2, down 1 over 2. I said up 1, back 1, up 1, back 2. I mean back 2. 2. Bum, 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 bum. Dashed, 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 dashed. So there it is, it's dashed. And its y is greater than, so I want the big Y values, so I'm up here. Now I have to solve for y. Alright, so I'm going to add over the 2x. 3y is less than or equal to 2x plus 9. Divide by 3, divide by 3, divide by 3. We get y is less than or equal to 2/3 x plus 3. So I'm starting at 3 with a slope of 2/3. 3, slope of 2/3. I said up 2 over 3, up 2 over 3. I said down 2, back 3, down 2, back 3. So this is a equal to, oh, so I forgot to say what it was. So y is less than, so I want the small y values, so I'm going to shade below, and it's a solid line. Okay, so solid line, shade below, shade below, shade below, shade below. Alright, that's it. That's the practice quiz. Book it, Nano.